Curves in industrial design. Analytic expressions for B-spline curves. The control polygon of a B-spline curve is different from the control polygon of its Bezier pieces. In this course, d sub 0, d sub 1, d sub 2, up to d sub m denote the control coefficients of the B-spline curve control polygon, while c sub 0, c sub 1, c sub 2, up to c sub n denote the control coefficients of the control polygon of a Bezier curve, or of the Bezier components of a B-spline curve. A cubic Bezier curve has an analytic expression as a linear combination of Bernstein basis polynomials. The coefficients c sub 0 to c sub 3 are the points of the control polygon. A B-spline curve expressed as a union of three Bezier pieces can be expressed in terms of the control points of the control polygons of these Bezier pieces. Here these are C0, C1, up to C7, C8, and C9. These are its coefficients with respect to the Bernstein basis. The same curve can be expressed in terms of the control points of the B-spline control polygon, here indicated D0, D1, D2, up to D5. These are the coefficients of the curve with respect to a different basis. When a uniform cubic B-spline with three Bezier pieces is defined for time from 0 to 3 and is expressed in terms of its Bezier coefficients, the expression is given piecewise and changes as time ranges from 0 to 1, 1 to 2, or 2 to 3. When the same uniform cubic B-spline with three Bezier pieces, defined over the same time interval, is given in terms of the B-spline coefficients, it admits a uniform expression in terms of the B-spline control points. We let d sub 0 to d sub m be the control polygon of a cubic B-spline. These are the coefficients of the parameterization of the curve with respect to a basis denoted by n sub 0, 3 to n sub m3. These basis functions play the same role for the B-spline curve as the Bernstein basis polynomials played for the Bezier curve. The curve admits an analytic expression as a linear combination of the B-spline basis functions, coefficients of which are the points of the B-spline control polygon. The basis functions themselves depend on the time interval over which t runs. N sub kn denotes a basis function. Here k means that the coefficient of n sub kn is d sub k. That is, n sub kn is the k plus first basis function. Here we have to remember that since the indices run from 0 to big N, d sub k is the k plus first coefficient. N is the degree of the B-spline curve, or equivalently the order of the basis function. T is the parameter. The basis function is defined for all t in the real line. The function vanishes except on a bounded interval where it is positive. The drawing depicts a basis function, n sub 2, 3. This is the third basis function, because k is 2, so k plus 1 is 3, and its order is 3, meaning it's a cubic B-spline curve. A uniform cubic B-spline, with t running from 0 to 3, is a linear combination of basis functions, n sub k3, as k runs from 0 to 5, with coefficients d sub 0 to d sub 5, which are the control coefficients of the control polygon. To each d corresponds a basis function.